Okay, so let's go. Number 1, sketch the Maxies, and the mark on that set of axes, it only needs to be a sketch really, but mark on there the coordinates 2 minus 3. So mark on there these coordinates. Just sketch it. Number 2, square root of 16. Here is a vector. It's got a length of 5, so that could be 5 newtons if it was a force, and the angle is 130 degrees. Sketch that vector. If you had to draw that out on a set of axes, what would it look like? Number 4, expand these brackets. In fact, I will change that slightly. You can. It's not, that's true. And number 5, the last one, we've got a cylinder. It's got a diameter of 3.4 times 10 to the 3 millimeters. So often we measure dimensions in millimeters, and the length of this cylinder is 0.024 times 10 to the 6 millimeters. What I want you to do is find out what the volume of that cylinder is. So that will require remembering the formula, putting in the values into the calculator and working out the volume. So I'll just pause the video here and you can have a go at them. Okay, let's have a quick look then. Number 1, coordinates. What we recognise is, and this is the convention, you need to know these conventions to be able to use it. That is assumed to be on the x-axis. That's assumed to be on the y-axis. So that means I'm going plus 2 along the x-axis. So that's assuming that this is positive and that's negative. That's positive and that's negative. And that's a convention that you're used to. So this is the x-axis here. So I'm going 2 along the x-axis and minus 3 down the y-axis. So if I do that, I'm going to end up at this point here. So if you did something along those lines, you've marked that coordinate. And what you've used here is what's called the rectangular or Cartesian, in honour of Descartes, who developed this geometry, coordinate system, the XY coordinate system. Cartesian. Cartesian. Yeah. Number 2, square root of 16? Not quite. Yep, but there are 2 possible answers whenever you square root a number. The square root of a number, right, plus or minus. If I square root a number, the original number could have been positive or negative. If you think about this, if I square negative 4, minus 4 times minus 4 is 16. If I square 4, I get 16. So going back the other way, I can't tell whether I started off with positive 4 or negative 4. And it's the case that whenever you square root a number, you always get 2 roots, 2 answers. What did I just say? When I square root a number, I always get 2 possible answers. It can be positive or negative. Okay. Number 3. Again, there are some conventions involved with this. I would set a scale. 1 centimetre, say, equals 1 newton, if this was force in newtons. So I'm going to draw a line 5 centimetres long to represent the force. The question is, what angle do I measure it from? The normal convention is always I measure angles from the positive x-axis, this axis. And I take anti-clockwise as being positive. That's the convention we always use, and you will remember that from last year, I think. So that means I have to measure around 130 degrees, so that's 90, that's 180. So guessing round about here somewhere is 130 degrees. So I'm going to draw a line out here, an angle of 130 degrees, and that line is whatever my scale is set to be. So that's that's the vector. What we're doing here is representing a quantity that has not only size, i.e. 5 newtons, but direction, a vector quantity. So all vectors can be represented like that. And the convention is this. Angles measured from that axis, anti-clockwise as being positive. I can go clockwise, but that would be a negative angle. Number 4, hopefully you remember you multiply every term in one bracket by every term in the other bracket. So I always start off with the first one and multiply it by every term in the other one, and then go to the second one. And just beware of signs, because a minus times a minus gives a positive. So I'm going to end up with 3 times 4 is 12. 3 times minus 3x is minus 9x. Minus 2x times 4 is minus 8x. Minus 2x times minus 3x is plus 6x squared. X times x gives x squared. I can go a further step because I can collect the x's to get 12 minus 17x plus 6x squared. Could anybody tell me what name I can give to this sort of expression? Sorry? Quadratic, well done. Because of the squared, the highest value of x is x squared. That makes it a quadratic. If the highest value of x was x cubed, it would be a cubic, and so on. This is a quadratic expression. And the last one, the formula for the volume of a cylinder is the area of the end, pi r squared, times the length. Hopefully you remember that. The radius is half the diameter, so half of 3.4 is 1.7. So I'd put into my calculator pi times 1.7 times 10 to the 3 squared times 0.024 times 10 to the 6. That's literally what I type into the calculator in one hit. And I'd get the volume, which would be... Did you get that, Sam? Who worked that out? If you haven't, do it now. 17.9 millimeters cubed, because it's a volume. Okay. Okay. One comment to make on that, Paul. What am I to do with that final answer? I might round that a bit further because I've only got 2 significant figures here and 2 here, so 2 in the answer. So I'd probably call it 220 times 10 to the 9 cubic millimeters to 2 significant figures. Save.